Hello and welcome to yet another video of Cornerstones of Math. In my last video, I have solved the system of linear equation and quadratic equation. You can check that video on top right corner of this video or in the description. Today, I am going to solve the system of linear equation and cubic equation. The equations are x plus y equals a and x cubed plus y cubed equals b, where a and b are constants. So let's call them equation 1 and equation 2. Just like my previous video, I will solve this in two methods. And these two methods are exactly the same methods that I have shown in my last video. The first method is simple substitution to eliminate one variable. From equation 1, we have y equals a minus x. Substituting this expression for y in equation 2, we have x cubed plus a minus x cubed equals b. So if we expand, we have x cubed plus a cubed minus 3a squared x plus 3ax squared minus x cubed equals b. Here, notice that x cubes get cancelled out, so we have 3ax squared minus 3a squared x plus a cubed minus b equals 0. Here we have the quadratic equation, so the next natural step is applying the famous quadratic formula, right? Well, no.
Nope.
The catch here is that we have a in front of x squared term. Therefore, if a equals 0, then the equation is not quadratic. This means that when solving this equation, we have to divide cases. And let us take a look at that special case right away. If a equals 0, then all terms with x become 0, but let us write that in the form of 0 times x squared plus 0 times x equals b. And here you still need to be careful, because now we have to divide cases depending on the value of b. If b equals 0, then the equation becomes 0 times x squared plus 0 times x equals 0. So x can have any values. And the equation 1 becomes x plus y equals 0, so we have the relation y equals minus x. This means that x and y can have any values that satisfy the relation y equals minus x. So we can write the roots as x equals some constant c, then y is given as minus c, where c can be any complex number. But if b is not equal to 0, then we just have 0 times x squared plus 0 times x equals some non-zero number b. Therefore, there exist no solutions in this case. So that was the case when a equals 0. Now let us take a look at the other case, where a is non-zero. Then, this previously obtained equation is indeed the quadratic equation, so we can use the quadratic formula to obtain x equals 3a squared plus minus square root of 3a squared, so 9a to the power of 4 minus 12a cubed minus b, and this entire thing divided by 6a. Therefore, this part can be simplified to a over 2, so a over 2 plus minus. Then for the inner part of the radical, we have 12ab minus 3a to the power of 4, so this divided by 6a. So this is x. And from the first equation, y is given as a minus x, so a minus a over 2 plus minus, and which gives a over 2 and now minus plus square root of 12ab minus 3a to the power of 4 divided by 6a. So this is the solution when a is non-zero. Therefore, the answer is, if both a and b are 0, then x and y are given as c, minus c, where c can be any complex numbers. And when a is 0 and b is non-zero, then we have no solutions. And when a is non-zero, then we have this specific solution. And these are the roots for all possible cases, hence the most general solution. The second method utilizes the relation between roots and coefficients of the quadratic equation, also known as Vieta's formulas, which is essentially obtaining the values of x plus y and xy first. Here, the left side of the equation 2 can be written as, by all-time famous formula, x plus y cubed minus 3xy times x plus y. So this equals b. And using the first equation, we have a cubed minus 3axy equals b. So 3axy equals a cubed minus b. I haven't divided both sides with 3a yet because we have to divide cases. If a equals 0, then we can write this as 0 times xy equals minus b. If b equals 0, then 0 times xy equals 0. Therefore, x and y can have any values. From equation 1, we now have x plus y equals 0, so y equals minus x. So we can write the roots as x comma y equals constant c comma minus c, where c can be any complex numbers. If b does not equal to 0, then 0 times xy equals b, which is non-zero, hence no solutions. If a is non-zero, then from this previous result, now we can divide both sides with 3a, so we have xy equals a cubed minus b over 3a. So now we have the sum x plus y and the product xy. These values mean that x and y are roots of the quadratic equation t squared minus at plus a cubed minus b over 3a equals 0. If we multiply 3a, we obtain 3at squared minus 3a squared t plus a cubed minus b equals 0. And this is the exact same equation we obtained in the first method. So we can just straight up use the previously obtained expression for roots, which was t equals a over 2 plus minus square root of 12ab minus 3 a to the power of 4 divided by 6a, meaning that x and y can have these values. So again, the answer is, when a and b are both zeros, then we have infinitely many solutions in the form of c comma minus c, and when a equals 0 but b is non-zero, then we have no solutions, and when a is non-zero, then we have these two pairs of x comma y. And that was all for today's video. Thank you for watching, and I will see you in another video.